Hello and welcome to this session. In this session, we are going to look at the I in solid, which is the fourth design principle. I stands for Interface Segregation Principle. This is often abbreviated as ISP. Let's look at what this principle says. It goes like this: no client should be forced to depend on methods it does not use. To explain this, as always, let's start with a real-world analogy. Assume you are working in an office which has around 200 employees. You have a bunch of printers, scanners, and fax machines available for the employees to use. As a software developer, you have been asked to represent these devices using object-oriented concepts in code. You have to design some interfaces too to ensure a certain level of uniformity among these devices. You start walking around the office floor and you spot this device. This is a multi-function, all-in-one Xerox work center that has a printer, scanner, copier, and a fax machine all built into one. You think that this could be a good starting point. You feel that if you can design a common interface based on this all-in-one device, that will give you a good start. So let's see this in code. First, you design an interface named I multifunction. The I prefix is just a convention that some programmers use to represent interfaces. Okay, so this interface defines methods that represent various functions. We have the print and get print spool details methods that are associated with printing. We have the scan and scan photo methods that are associated with scanning. The fax and internet fax methods deal with fax related functions. Now you create a concrete class that represents this particular device, the Xerox Work Center. You make it implement the I multifunction interface. So you will have to implement all the 6 methods. Very well, you implement all the 6 methods. All good. Now you walk over to the next room in your office. There you have another device. This is an HP printer cum scanner device. It's not as multifaceted as the Xerox Work Center, but it can still do a couple of functions, printing and scanning. So let's come up with a concrete class to represent this HP device. Our common interface I multifunction has all printing and scanning related methods, so we will make this class implement the I multifunction interface. So we implement the print, get print spool details, scan, and scan photo methods. What about the other methods in the interface? If you are implementing an interface, you have to implement all methods in it. So what we will do is we will implement the fax and internet fax method and give it a blank implementation. This machine does not have the ability to send or receive fax, which is why we have to leave these fax-related methods unimplemented. Now you keep walking in your office and reach another room with a Canon device. This device is a printer and has printing functions alone. So we will create a class to represent this device and make it implement the I multifunction interface again. We will implement the print and get print spool details methods, but then we will have to implement all the other methods as well and leave the implementations blank. So scan photo, fax, internet fax, leave it all blank. Now you start seeing the problem. Unimplemented methods are almost always indicative of a poor design. This goes against the interface segregation principle, which says no client should be forced to depend on methods it does not use. So what is the problem if we don't fix this? Why is this a bad design? We leave the methods blank. What's the big deal? Assume you have an employee portal application in your office that needs to directly access these devices. So you have to provide these device classes packaged as a library to a group of programmers who are working on this employee portal. One programmer wants to send a fax. He sees the fax method on your Canon device class and invokes it. He does not care to look inside the method and understand that it is a blank implementation. He does not need to, in fact. All the programmer sees is the fax method on the Canon class, assumes that this device has the ability to send a fax and invokes it from the employee portal. This is calling for trouble, and the code will definitely break because this method implementation is blank. So this is the reason why this is a bad design. And this is why interface segregation principle recommends to avoid such designs. So in this session, we have only covered what the problem is. In the next session, we will take a look at how we can fix this. So that's it for this session, and I'll see you in the next one.